Alright, so to understand the process by which we get these types of hybridization in CO2, sp2 hybridization on the oxygens and the sp hybridization on the carbon, we need to go back to where we started in the last unit. And in the last unit, I showed you an illustration like this, and we talked about how we hybridized, or how we did not have any hybridization. This is the unhybridized set of orbitals for the electrons in the highest energy level. We call that highest energy level the valence level. And this is what we did in the last unit. We had a set of p orbitals here, a set of p orbitals here running 90 degrees to each other, and a set of p orbitals that are running 90 degrees to both of those. So this p orbital comes out away from the paper and back behind, and this goes vertical and this is horizontal. And so this is when the atom is in a gaseous state, it's too far apart from anything else to do any bonding, and it's not touching anything else, and it's not reacting, and it's in its lowest energy state. So we have this ground state arrangement of valence level orbitals. Okay? Now, if I hybridize all four of these valence orbitals in order to do covalent bonding, and you have to hybridize to do covalent bonding. Covalent bonding doesn't occur until you do, or along with doing that. If I hybridize the s orbital, this spherical, surrounding the whole thing, ball-shaped s orbital, if I also hybridize this p orbital that's vertical, this p orbital that's horizontal, and this p orbital that's going out toward you and back behind the paper, if I hybridize all four of those, I get this, and it's called sp3. And I call it sp3 because I've hybridized one s orbital and 1, 2, 3 p orbitals. So this superscript just means we started out with 3 p orbitals. The s here means I started out with an s orbital, and I've hybridized all four of those to make this hybrid set of 4 single balloon sort of shaped orbitals. Okay? That's where we started. If, on the other hand, I only hybridize 2 p's and not 3. We always hybridize the s if we're going to do covalent bonding. That always happens. But if I hybridize only 2 p's, so I'm leaving, say, this vertical p alone, I'm not going to hybridize it because this is going to be involved in some kind of pi bond. If I hybridize only 2 p's, we don't call it sp3, we call it sp2. And so in carbon dioxide, I had to leave this p orbital that forms this pi bond. So this was originally, let's see here. So what I had before I do any bonding, I have a p orbital that is unhybridized. Okay? All right? That's going to allow us to go and pi bond to something out here. All right? But I hybridize the s and 2 p's. Therefore, I have a hybrid sp2, another hybrid sp2, and a third hybrid sp2. And that's where we get this hybridization from. Or this one as well. Because I leave one p orbital unhybridized. Okay? Does that help you? So these are unhybridized p orbital. Remember, p orbital has a double balloon shape. It comes in 2 parts. Okay? Got that? All right. Now for the carbon here, I've hybridized only 2 orbitals. I've hybridized one s and one p. So that makes an sp, or makes 2 sp orbitals. Okay? This is an sp hybridization. This is an sp2 hybridization. Okay? So I've got 2 p orbitals that are not hybridized. One p orbital is here, and another p orbital is running 90 degrees to that. And you'll see when you do your balloon shapes today how that actually looks in space. Okay, or at least you get a better idea from it, I hope. So this is one. I'm sorry, it should be unhybridized. Here and here, and this is another unhybridized p orbital.
So why are the materials that come off of carbon sp and not sp2 recommended to multiply?
Because I've only hybridized S and P. Over here I hybridized S, P, P. Got that?
How can you tell that balloon is an S instead of a P?
This is not an S. It's an SP hybrid. It's a single balloon shape. Now I've made these the same color. Up to now we've been making the orbitals a different color when we do separate orbitals, okay? So this is a separate SP from this SP.
I'm saying like, it's called an sp2 because you hybridized an S. But how do you know which balloon is an S orbital?
How do you know which hybrid came from the s orbital? Doesn't really matter. You don't have to know which one came from the s orbital because when you hybridize it, it's exactly the same as these two. So which one came from which is really doesn't really matter.
So if there's three balloons like that, it's just the sp2.
Pretty much.
I'm so confused about how getting an sp, like how an sp2 would work. Is it only if you're highlighting one sp?
If you only hybridize one S and one P, that's SP. One S, one P, SP. If I hybridize one S, an S orbital, and two P orbitals, that's SP2. If I hybridize an S and three P's, that's SP3. Does that make sense? And so the P orbitals here and here on this carbon and this oxygen, those are going to overlap to make that pi bond up here. Okay, and I'm not showing the other pi bond going the other way down here in this part of the drawing. Okay? All right then. So that's the balloon model you're going to make. Now you're going to need at least 3 long balloons. If you have the really long balloons like I use, like I've shown you before, you can get away with doing this with 3 balloons. Okay? So 3 long balloons. And in this case, you are going to tie a knot about 2.5 centimeters from the end of each one of these 3 balloons to start. Okay? And you're going to need 4 round balloons to make this model. The carbon in your model is going to be where all the balloons are knotted together, and the oxygens in your model are going to be where all your balloons are knotted together. Okay? So I'm going to recommend to you that you do it this way. Let's make both of these sigma bonds first. Okay? Then make your double balloons on each end. And then do the pi bonds, the 2 separate pi bonds, the last thing. Okay? So start by tying a knot in the end of one of these long balloons. Okay? Blow up a section that's about 8 to 9 inches, tie a knot. Blow up another section that's 8 to 9 inches and tie a knot. And then you're going to put your 2 round balloons, or 4, 2 on each end, at the very end of all of that. Okay? That's where I'd like you to start.
Tie a knot in all of these, right?
Huh? All of these are going to need a knot in the end, yes.